For the English speakers amongst us, I will first make the introductions in Hebrew and some housekeeping, and then I will repeat it all in English. צהריים טובים, אני אהבה כהן מהספרייה הלאומית, וברוכים הבאים להרצאה החמישית בסדרת חגיגות העשור ל-RDA ומזל בארץ. כולנו שומעים כל הזמן על בינה מלאכותית בקטלוג, אז היום הזמנו שתי ספרניות מספריית הקונגרס, קרולין סקוצ'י ואביגיל פאטר, לדבר על מה שנעשה אצלם, איזה ניסוי שנעשה אצלם, ומה התוצאות ומה ההשלכות לספרייה שלהם. אם יש לכם שאלות במשך ההרצאה, אתם מוזמנים לשים אותם ב-Q&A או בעברית או באנגלית. אם זה בעברית, אני אקריא את זה ואתרגם למרצות. Welcome to the fifth lecture in our series celebrating 10 years of RDA and cooperative authority cataloging in Israel. A big issue in cataloging is what's called AI, but really isn't. And so we invited two Library of Congress staff members, Carolyn Saccucci and Abigail Potter, to talk about the experiment that was held at Library of Congress in exploring computational description, how it went, and what the implications were and are expected to be at the library. If you have any questions, feel free to put them in the Q&A, and at the end, I will read out the questions so that they can be answered. Caroline and Abigail, over to you.
Thank you so much, and thank you to the Israeli cataloging community for inviting us to speak today. I am the Library of Congress Collection Services side of the house of the Library of Congress, and Abigail is on the IT side in the Office of the Chief Information Officer. So we've been working together from both sides of the department of this, a very large institution, to lead this project together. Next slide, please.
Thanks. Yeah, I echo thanks. And we're happy to be here and share this with you today. Like Caroline said, I'm in the IT part of the library called the Office of the Chief Information Officer in a department called LC Labs, and we do experiments with groups and departments across the library. And we've been looking into machine learning since 2016, mainly because we wanted to use it to help provide enhanced access to our collections, especially our digital collections. And based on the different explorations and experiments we've done, we've developed this AI planning framework. And because AI became such a big hot topic as we were doing the work. If you're interested in learning more about the framework, this presentation is primarily about the experiment that we did, but the experiment helped sort of flesh out this framework and continues to be useful in other experiments we're doing in AI. But the basic phases are to first understand it, the use case, what it is you're trying to do with the tool, then to experiment with it. We use experiment because we're labs and we use that language, but you could think of it as testing or verifying, prototyping. You basically want to test the tools with your own data and review the results, preferably by people who know what a good enough result would be. So, and that depending on the use case, who that is. In this experiment, it's catalogers. So that step is super important because in our tests, AI is a powerful tool, but there's still risks involved in it, and errors are the biggest one that we've seen, errors and biased data, and we'll talk more about that in a minute. And then when we get to implementation, there's a whole other set of considerations to think about when you're at the implementation stage, how that integrates with your, how the tools integrate with what you have, how what the cost and benefit analysis is, with all the other priorities that we have, how does this line up? And then, do we have sort of shared standards and shared practices around understanding and using the data that comes out of AI processes? And then, of course, this is all sort of built on existing governance and policy, and sometimes new governance and policy. And at the Library of Congress, we are in the process now of refining our policies around how we're going to use AI. Right now, we have a kind of moratorium on using generative AI to create Library of Congress products for the public, with exceptions for experimentation and testing, which is exactly what we're doing right now. This is sort of a zoomed in version of that last slide of sort of what kinds of activities happen in each of these phases. I always say the best place to start is sort of defining the principles and values of and even the sort of design principles of the use case that you're trying to explore. So for this use case, it was sort of keeping the catalogers at the center and their expertise at the center, and designing the prototypes to assist catalogers. That human in the loop is really important, and we knew it would be from the very beginning, because not all of the data that comes out of AI is reliable, so it has to be checked for really important data like cataloging data. And then there's there's tools and sort of worksheets that we defined to help groups work through these phases and activities. But like I said, if you're interested in these, there's more information about that. But we're walking through all of these now as we move towards perhaps looking at implementing a tool like the one we've been experimenting with. But I won't go too much into this, but if you're interested, I can come back. But one of the pieces of that's important to call out that we're using in this experiment too is this data processing plan. So we're working with a vendor to do the technical kind of testing of the tools and the models. But we're asking and it's part of the contract requirements that they fill out this data processing plan that identifies exactly what data, exactly what model they used, how they trained the model, how they prepared the data for the model. So we have that kind of traceable information for ourselves, so we can manage this over time, and so we can sort of share it with users if they're interested. It's sort of trying to be transparent and learn as much as we can when we do these experiments. Okay, I'll hand it over to Caroline to talk more specifically about the cataloging experiment.
Thanks, Abigail. So our research questions for the two experiments were, well, the first one was the most basic. Obviously, we built on it on the second one. So we were trying to see what methods could be used to extract ebook metadata from ebooks themselves. We wanted to understand the performance baselines, like what are the baseline expectations, and then understand sort of the basic data quality and try to set benchmarks if we could. In the second experiment, we provided even more ebook data for training and tuning models. The output was in valid mark, and they created prototypes for using a human-in-the-loop catalog assistance workflows. They did a little bit of that in the first experiment, but they built on it, obviously, in the second experiment. Next slide, please. So in the first experiment, the ground truth data for testing and validation was about 23,000 different ebook types. So we had titles from the cataloging and publication program, open access ebooks, ebooks coming from the copyright e-deposit workflow. So that's a workflow where publishers submit titles in electronic format as opposed to print. And then legal reports. These are documents that are reports curated and created by legal reference specialists in the Law Library of Congress. And so all of those combined along with all of the associated catalog records. So these are already fully cataloged ebooks. And we wanted the experiment to be able to predict author, title, creation date, issuance date, form or genre, subject, Library of Congress control number, and ISBN. So, and then most of, as you can imagine, we're in the United States, most of the material that we were working with in these programs is English language. There was some German and Spanish, but mostly English. The combination of EPUB and PDF formats. And we did not select the training data to be specifically targeted to any subject or genre or anything. It was just boom, here to have a bunch of content. In the second experiment, we gave them all of the ebooks that we had through the SIP program, because what we'd learned, and we'll talk about this later, but what we learned was that we didn't give them enough. It was too few to work with, actually. More is more when you get to AI experimentation and AI workflows. So we gave them almost 120,000 titles to work with. And we wanted them to get the output in MARC. So these were the specific fields in the MARC format designation that we expected them to be able to identify through the workflows. Next slide, please.
And I think I'm doing this one. Yep. So in the first experiment, these are what specific models were tested. So in the first experiment, we asked the contractors to specifically test different models so we could see the performance, how those models performed with our data. We asked, and this was before ChatGPT 3.5 came out. So this was, they tested non-large language models. So BERT, Spacey, and some, sort of more traditional machine learning and data science models that did things like token classification, which, recognizes words or phrases, and then text classification, which is describing what the text is about, the sort of topic of a group of text, and then data serialization, which sort of breaks out the output in a certain format. So those were the models that we tested in the first round. And then there was a human in the loop prototype that we used to have the catalogers review the output. So those prototypes were developed after speaking with catalogers. We had a couple workshops with catalogers asking them, where would you want AI to help you in the workflow? So that's sort of what drove the design of those prototypes. In ECD2, which was the second phase of the experiment, after we sort of learned in the first one, we kind of wanted to see, like, is this possible? Could we get, would this assist our catalogers? And we sort of thought, yes, it can, based on ECD1. And then ECD2, we'll talk more about the results in a second, but ECD2, we wanted to do more testing of the prototypes, and then we wanted to test those large language models. And we are working with Mistral AI primarily because it is open source and because of their terms of service. So and then they tested both prompting the LLM, the large language model, and then fine-tuning the large language model, and then using vector search to match field to match records based on sort of fields that are showing up in the records. And the results, I think I'm doing this one too. The results, so the first one, we basically, in those tests, we saw that that they were able to sort of pick up the token classification was pretty successful. The subjects even though the subjects were identified as what the catalogers would like assistance with, those were pretty hard to do. The sort of text classification task was still pretty difficult for those models to do accurately. And there's many reasons for this, and part of it is we did not sort of give them a curated training set, a balanced training set. The way that we do subject cataloging is hierarchical, and there's many, many terms. Many, half of them are used once. So it's a pretty hard task for humans and for machines to do. But in those prototypes, we really did find that the catalogers were receptive to the suggestions, to the help, and we thought that we were kind of surprised by that, but we're continuing to build on it. And that it's been pointed out that we heard that from the people who did the testing, who sort of volunteered themselves. So, which, that's true. But it was, sort of putting the cataloger at the center of it and letting them make the final decision, I think was a big factor there. And then there's also some experimentation about the kinds of additional information that was shown to the cataloger and presented to the cataloger in the workflow. So that was interesting, and the contractor sort of iterated on that and the other prototypes. In ECD2, we wanted to see, okay, these models can suggest some terms that are that are helpful. Can it make a valid MARC record? So this was a harder task for the data output part of the experiment. But we were able to see about 80% accuracy across the fields and subfields, which is not good enough to fully automate. We still have to have a cataloger review that, but we're sort of asking questions around, okay, is that the kind of assistance that's really helpful to the catalogers? And still, subjects continue to be difficult, and were accurate only 46% of the time. But we did see that with the LLMs, we could use them to produce structured data, to produce a subfield data, and that the fine-tuning method of working with the models was better than the prompting. This is some of the metrics, the automatic metrics. So we compared what the machines did to those catalog records. That's how they developed these metrics. So we compared the catalog records that the Library of Congress staff already produced to what the models produced. And you can see here, this is ECD1, and we're in this sort of range of 80%, some up to 100% for ISBN and LCCN. And then the genres, I think there were only 14% of the records had genre terms. So that's one reason why this was a pretty low metric. And then dates didn't perform that well. But you can see, and here's the ECD2 scores. So we're in the 80 range, except for the dates and the subjects. We improved a lot on genre with the large language models, but you can sort of see there isn't, the large language models are, we'll get into this a little bit later. Large language models are powerful, but are they much more powerful than the sort of more traditional models? Those are things that we're looking at when we look at other considerations when we want to use these tools. Okay, I'll hand it to Caroline to talk more deeply through the sort of subject classification topic.
Yeah, so this is one of my favorite slides to talk about, because it gives such a great example of the kinds of issues that come up with text classification, subject identification. And in case I don't know that we maybe glossed over it, token classification is the ability of the machine model to identify that a series of a string of text, whether it's words, numbers, is a thing, is a title, is an author, is a publisher name, is a whatever. Text classification, or is an identifier, is an ISBN, is a Library of Congress control number. Text classification is the ability to take a set of text and identify from it what it thinks the main topics are, and to figure out what the controlled vocabulary term ought to be. So it's a much more complicated process, and much more deep learning, if you will, for a process to achieve. And sometimes you hear of abstractive text or extractive text. Abstractive is it's looking at a bunch of text and presenting to you what it thinks it means. Extractive text is it's taking from a set of text and identifying what it thinks are the main sentences, for instance, that give you a sense of what this is about. So one is taking from the text, whole strings and saying, this is what this is about. Abstractive is it's taking a bunch of text, but then telling you what it thinks it means, which is another a deep learning thing. And so all of this is sort of along the lines of text classification. Subject cataloging is text classification. So for that, we used ANF. ANF was one of the 5 models in the first. This is an example from the first experiment, and ANF was one of the 5 models that was selected for use. And this is a great example of what can go wrong. So the title on the left, Moontrap by Don Barry. What you see in the grid is all of the subject headings that the machine learning model presented. What's in white what's in green are what are matching with the mark XML that was used as the validation. The white strings are all what the machine learning model predicted that were not in the original mark record. What you do not see is what was in the original mark record that actually never got selected by the model. So if you went back to the original mark record, you would see other subject headings. So this only will show you what it matched and what it identified, even if it didn't match what was in the original. So what's interesting, of course, are, we all can sort of, berries, that's Don Barry is the author, and it sees that this is a very important word. So therefore we will make berries is the closest term that we can find. And again, I should mention, this is all against linked data. This is all using the library, the LOC, id.loc.gov for being able to match against. So if the term berries is the closest one, note that there's no berries fiction. It does not identify that it's fiction. It knows that fiction is a free floating term that does not necessarily, there's no URI, linked data form for Barry's fiction. That has never been created, therefore it's not going to find it in ANF. But note that it doesn't select fiction for any of the terms that it identifies. So how does it know whether it's fiction? So that's a question that is like, it's not like a book says all over itself, I'm a work of fiction. You might see that inside on the copyright page where it's in teeny tiny script, this is a work of fiction. But other than that, there's nothing to say that the work is a fiction. So how would it know? So that's always a question. What's interesting is we don't know where cyberspace and beats persons came from in the work. Like what is that? Where does that? How did it come up with that? So that's a complete misleading, harmful. If someone were trying to find a title about cyberspace and this one came up, like what this is not useful. So the ones that it selected, great, fantastic. Oregon, Clackamas River Valley, Willamette River, Oregon. Those are semantically close to the actual terms used in the LCSH, used in the original mark record. So the question about, okay, well, how good is good enough when it comes to semantic, relatively close in the general region, is that close enough? So these all provide some really interesting sort of thought questions of what we want and expect. What does harm? What does no harm? And obviously the terms, not every cataloger agrees on terms. So, these might only be the 5 terms that someone would have selected, but there's maybe 3 or 4 others that you don't see in this record. Well, maybe another cataloger would not have selected those other 3. So it's not like it's necessarily right or wrong, but it does present some interesting ideas to think about when it comes to subject cataloging using machine learning workflows. Next slide, please. And is this me? I don't see a number on the slide.
I can do it. It just shows the ECD2 results from the manual subject review. So in a second, we'll show you like a screenshot of the prototypes and how they made these decisions. But and and we ask them these questions: are these subject terms acceptable? So even if it doesn't match, is it still acceptable? It doesn't match what the other cataloger did in the original record. Or is it just wrong? Is it a hallucination? Is it, is it just way off base? Or is it close, but maybe too narrow, or, too broad, like Caroline was just describing? Semantically, is it sort of a broader topic of what you would choose? So this, still you see, acceptable 42.9, that's not a very high score, but there may be some, wiggle room here in these too narrow, too broad, and trying to think through, what are the implications for this if we were to create a workflow like this. And then Caroline can jump in here, because we asked for feedback from the catalogers also about what they saw when they were doing the reviews.
Yeah, so we had, just for ECD2, we had 20 catalogers reviewing this work. And we asked them to identify whether or not something was wrong, outright just wrong, or if there were broader, narrower, and so on, and acceptable. So of the wrong, the interesting things that we got were like, oh, well, it's wrong because it was the wrong subdivision order, or it's wrong because it was too broad and there should have been a geographic subdivision. So perhaps it was just cats, but not cats in Greece, for instance. Subject was too narrow because the geographic subdivision did not include all the places covered by the work. So it left out a place. The mark field numbers, tag numbers were not right. The subdivisions were provided as its own subject instead of being for the entire subject. So what we sort of took from that is it has a really hard time identifying subject cataloging rules. And that the syntax that we use for LCSH is so complicated that we don't have the rules. First of all, if you're familiar with Library of Congress subject headings, they are extraordinarily, the policies that are the rules of how to formulate a heading are so complicated. And it's not like we fed the machine, hey, these are all the rules, and see if you can figure this out and try to match it correctly. We were doing this with, hey, can you just see what exists out there as ID in id.loc.gov as URIs? That might be possible. So it makes one wonder. Makes me wonder about the use of the appropriate use of lengthy subject strings and free floating subdivisions and other kinds of things that we do to make subject cataloging what it's been for the last 100 years. Next slide, please. So the next couple of slides are showing the actual prototypes. So this is the first model, the first experiment. We used, developed a very low fidelity prototype for presenting subject terms. And there was another prototype for names and from a name authority file. Because the two areas where and we did some workshopping with catalogers, like what are the pain points in cataloging? And one of them is, it's something that intellectually identifying what are the subjects. So that was one. And then also, it's nice that if the machine can tell us what the name of the author is based on the presentation on the title page, fantastic. But can it tell us what the actual name authority, like identify the right name authority in the authority file? So that's like another step level. So two prototypes. And so this particular one is just subject. And the cataloger could select a title, but you don't see if there was a drop down that showed some information about the MARC record, not the subjects, but just say the cataloger could see the MARC record, most of the fields. And then that abstractive text and extractive text. And that was supposed to be helping the cataloger figure out what is this book about. Sort of like these are the summaries, only using the machine learning model to identify the summaries. And there was very much a hit or miss on how well the machine learning model did, because it was really only looking through the first up to 50 pages of an ebook, and predominantly the first 5 to 10 pages of an ebook. And if you're familiar with the way, especially research oriented titles are presented, a lot of the time it's all about the author or authors if it's an edited work. So instead of getting into the introduction, what they're really looking at is all the things that all the authors have ever done. But that's not going to tell you what the book is about. So if it's going to take it from that, you're going to get a very low quality extractive text or abstractive text. And there were other reasons why it wasn't great at doing this, because of course we were giving them every kind of thing. We were giving them legal reports, we were giving them children's ebooks, we were giving them like any number of things, and how well was it going to be able to do with all of that? So this is a plug for curating. Make sure that you think about what you want to give them. For us, it was like, here, take it all. And they did try to do some parsing and some curating on their own. When I say they, we were working with a vendor. So the vendor was trying to do that work. But obviously, always a good best practice with doing anything like this is think about the data that you're trying to feed the model. And then the prototype would suggest subject terms. And the cataloger could say whether or not the terms were if they liked the terms or not, and then they could validate against what the model actually predicted. And it was just an opportunity for cataloger to see what it could look like to have terms presented to them to select, because maybe instead of selecting all the subject terms for the cataloger, the machine learning process could suggest terms for the cataloger, which is a different concept than just doing it for them. Next slide, please. In ECD2, it was an expansion of that prototype, where now the cataloger was presented with a whole range of subject terms. And if you can, I don't know can you get your mouse to show on the tab image there? So the cataloger could select the image and it would show the ebook. Then the metadata showed the MARC information, or MARC XML. And then these are the related records this is that vector searching that Abby talked about, where a cataloger, at least I was trained as a cataloger, I certainly would want to go in the catalog and see what do other books that are about this topic, what subject terms that it select were selected for those topics, right? And so that's what this vector searching was doing. And so then these are the terms that other works had. So on the left side of the screen are different parts of the records. So you can see the information there. And not only, these are the things that the machine learning model predicted as title, as author, as date of publication. And those metrics were fed into the graph that you saw. But at the subject, that one, and then summaries, one over, again, abstractive, extractive summaries. If you click on, if you go to the next slide, this is a zooming in of that subject identification. So this is where the cataloger could say, oh, this was an acceptable term, or this was too broad, too narrow, and it was outright wrong. And the outright wrong is where it was like definitely wrong. And then they could put a comment in. And so you can see, for instance, the television broadcasting, the very last one, original prediction, history 20th century Europe Eastern. I don't think that follows LCSH syntax. And so it would be, so that's what the machine selected, but the other terms were what a cataloger might want to select. So that's why it was giving the option for the cataloger to say whether or not other terms might have worked. Next slide, please. And this is you.
Yep. So in these experiments, we're assessing and evaluating a lot of different things. So the metrics, the sort of comparing what the machines produced versus what the catalogers did. And this is from ECD1, sort of a summary of all those metrics. And so those are something to look at, but they don't give you the whole picture. There's also other considerations. So this is a graphic that the vendor created that's based on that. This is also from the first experiment, where these are the different models that they tested, and then they scored them according to, you know, how reliable, like how easy and reliable was the model to run, how much compute cost was expended. Compute cost usually translates into how much it cost in money to run it. How easy it was to add our own training data and tune and train the model. Is the model currently active? Are people working on it? Is the documentation good? Is it easy for a developer to pick up and use? So those are, and there's probably more, I think, that we would want to kind of think through and look at when we're choosing different models or approaches that we may want to use. But that's sort of what the contractor came up with in the first experiment. And then there's the feedback from the catalogers themselves. So what their comments are, what their scoring is, which I think gives you sort of a larger picture of actual performance. The feedback from the experts, is this useful to them, is important to assess. So when we're going back to the planning framework a bit, this is how we're thinking about assessing the outcomes of the experiment and how we think through the different evaluations we have to do. So we think through, okay, when we're looking at the output and we're thinking of how to implement this in our workflows, is this responsible? We have 3 different buckets we're thinking of now. So the responsible bucket, is there a balance of risks and benefits? Is it worth it? So there's risks in these tools. Error is one. There's bias in data. That's another. There's certain operational kind of risks around security and privacy and legal constraints. There's big questions about the use of copyrighted material. Were some of these models trained on copyrighted material? So, and then different organizations have different rules. So, like in the federal sector, where we have specific rules about privacy. So we have to look at these terms of service, look at the tools that we want to use, and understand if they're compliant with all of our rules. And then we're also looking at, the library has just recently finalized AI principles. So when we are implementing these tools, what does that look like? So so we have established principles like supporting public trust, supporting the public good and the trustworthiness of our organization. We don't want to implement these tools in a way that lowers the quality of our products. We want to implement these in a way that helps increase the trust that we have with our users. And then other things about principles about protecting rights, copyrights, other types of rights, and also sort of making sure that we're accountable. So, we want to use these tools in a responsible way, that the library remains responsible for the quality of our products and services, and we want these tools to sort of underline and increase quality and increase connection. And that is something you don't know until you sort of test what the tool is and how and what it can do and how the staff are going to use it. Then there's also another bucket about just is the output good enough? Is it effective? Is it helpful? Did you test it? What kind of data do we test it with? Caroline keeps talking about it's a huge issue, the quality of the data that you use to tune or test with these models. It it directly impacts the performance and the quality of the output. And, reviewed by our experts. So did the catalogers find the data to be quality enough? And do we have standards? Can we articulate what quality means and have, metrics that we can and benchmarks that we can meet? And then practical. So these are the concern, sort of looking at these models too, are these cost effective? I think there's not a lot of information about how these tools are going to cost over the long term. How can we understand what the costs are going to be? How can we integrate these tools with our existing infrastructure, with our existing staff? And how could one feature of AI is that it can change, the models can change as it sees more data. So how can we ensure that the performance is stable over time, that the performance stays good? That's sort of another sort of planning and program process that we have to develop. So these are the kinds of things that we see promise, but it's not like a turnkey solution for us. It's something that we have to think pretty carefully about, and this is how we're approaching that right now. Okay, over to Carolyn.
So some of the things that really rose to the surface for me in terms of like trends and themes, as I mentioned before, that more and carefully constructed training data is really necessary to make a successful, well, in this case, experiment, but of course, a project. One of the things that we see is that half the training data contain some similar patterns of LCSH, and half of the training data contain unique LCSH. And it's very difficult to make predictions when it's that random. And incidentally, in the whole spectrum of all bibliographic data, if you think about LCSH being this massive vocabulary, half of the LCSH gets used often, or at least more than once or twice, and half of LCSH is only ever used once for that particular title for which that LCSH was proposed. So there's an extra layer of randomness, if you will. So it just makes it extra complicated, not to mention all of the rules of syntax. So that's just a thing to know, which is another reason why it's important to remember that it's better perhaps to have suggestion service of AI doing that kind of a thing as opposed to just doing the subject cataloging for the record without anyone looking at it. There's too much randomness to happen there. We did see though that catalogers reacted more positively than we expected. They seemed, once they could see what it was doing, it wasn't just boom creating the whole bibliographic record for them. It was predicting some things for them, and then also suggesting some things for them, which needs their intellectual artistry of cataloging to be able to do a good job with it. It's both and. You can't have one without the other. But I think they really got excited about it, and were really keen to engage with it. And the human in the loop prototypes showed the most promise for future experimentation. So moving forward, that will be the way we're going to be working with AI in the course of the experiments, which we will talk about, I think, in the next slide. Plans for the next. Oh, no, first, my continuing questions. Okay. So with that whole idea of syntax of LCSH being so complicated, what faceted subject headings, post-coordinated headings, being more successful than our very lengthy pre-coordinated subject strings? And then maybe we could get away from some of those problems of which comes first, or which subdivisions are acceptable with this term, why can't we say religious aspects goes with any term? It's only these terms that it can be used with. Why can't we use it here? I mean, these are the kinds of things that machine learning process, like, whoa, what do you do with that? Which subject categories are more successfully cataloged using machine learning? Are social sciences more complicated than art? Is mathematics more complicated than literature? Would one be better than the other? Could a model be trained to accurately predict Library of Congress classification or Dewey Decimal Classification? I know that OCLC right now is trying to work on a project with Dewey Decimal Classification. The National Library of Germany has been working with Dewey Decimal Classification. In the case of the German National Library, it's very, very targeted to medical titles. And even then, it's not always a great output. So, and even then, they're using short numbers, not lengthy Dewey, standard Dewey numbers. So an LC classification, if you work with that or familiar with it, it's extremely idiosyncratic. So again, it's you know, there's a lot to think about with that. And then what will the library's policies be? And this is, of course, Library of Congress policies be about copyright concerns. Copyright, of course, is major. We have the U.S. Copyright Office and are under the umbrella of the Library of Congress, so that's very near and dear to our hearts. Accuracy versus relevancy, you know, is how, you know, is perfect at the risk of good, or, you know, whatever that truism is about, you know, what's good enough, what's acceptable. And then training data bias. So if what you give, this has to do with what you're training, what you're using as training data, but certainly garbage in, garbage out. So, you know, bias in, bias out. So thinking about that as well. Those are all kinds of how do we continue moving forward with this. Next slide. Okay, so this is where we're going now. We are still working on the experiment. We are in ECD3. It's a year-long. Each one has been a year-long project, so we're in the middle of year 3. And this particular project is specific to the cataloging publication workflow, the pre-publication workflow. The first 2 experiments were published materials already. We already had the ebooks. In the SIP workflow, every single SIP request has a PDF galley attached to it. A galley is the pre-publication proof used to identify all the metadata. Because we give a full MARC record with subject cataloging, LC classification, and Dewey with each SIP title. So how can SIP metadata, how can that workflow be augmented with a machine learning process? How can SIP metadata be generated and through a machine learning process and bid frame data be extracted? And then how can additional elements to the bid frame description improve quality and usefulness compared to the metadata extracted for ECD1 and ECD2? So in addition to the title, author, subject, blah, 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 there's also, does it have illustrations? What is the audience level? What language is it in? Does it have bibliographic references or indexes? I think there are, what is the name of the publisher? What is the name of the place of where was it published? There are more metadata that we expect to have in a fully cataloged record. Things that we would never expect an AI workflow to identify is this a translation? Was this a master's thesis or a dissertation before it became a published work? If it's a translation, what was the original title? I mean, these are the things that catalogers need to be thinking about. What languages did it also appear in? When we have a book that's that they've learned that it really doesn't matter much beyond the first 20 to 30 pages, then well, what if there's a whole back of the book that's in a different language? Would it be able to identify that if it's a bilingual text? The first 100 pages is in English and the second 100 pages in French. So there's a lot of things that, or, you know, a bound width is, I mean, are there, granted, a pre-publication wouldn't have a bound width, but you get my point. The idea of, oh, I just lost my train of thought about another kind of situation. Cover titles, all of these things that you get into when you're actually cataloging something. There's only so much a machine can do, right? Which I hope is giving you all some relief to say that there's really no way that the machine learning process can completely take over the cataloger's job, because there's too much else that a cataloger has to think about beyond the basic things. So also in this experiment that we're doing right now, the data, we're using data that more closely matches what catalogers work with on a daily basis, because the workflow that's the SIP workflow is a very high priority, heavy daily workload. We catalog over 30,000 SIP requests a year. And it's done by a staff of I don't know, 60 staff, more or less, working in a couple of divisions of where I work. And so it's a very heavy workload. So how can the machine learning process help with that? Not some like, oh, these ebooks are sitting in abeyance waiting for someone to deal with them. This is publishers are waiting for this metadata. We need to get it to them. How can we get it? How can we use machine learning to expedite and help with daily workflows? And also, can it create bibframe descriptions that catalogers can review in the linked data editor? They'll be loaded to the bibframe database, the test instance of the bibframe database. And the hope is that in not necessarily real time, because what we're doing is taking that we provided them with 100,000 galleys of already cataloged SIP books. So those are the SIP records that are generated already are available in bibframe. As you probably know, all of the MARC data in the Library of Congress catalog exists in bibframe as well, because it's been converted. And so the bibframe data as validation data exists, and the machine learning process, they'll take these already cataloged galleys, run them through a model, and then create bibframe data based on that. And then the cataloger will be able to review how well did the bibframe data that's exported output by the model do against the original MARC record, against the original bibframe metadata. And this is the first instance of actually creating native bibframe for the SIP program. So it's kind of an exciting thing to be working with. And of course, there'll be an extension of the cataloger assisted prototypes of looking at, this is the bibframe data, and then these are the subject terms, and these are how do you think that the model did as a cataloger review. Next slide, please.
And then this is this is our last slide. It's the kind of recap of the 3 phases so far, and then looking at the next phase is really thinking through the requirements for production. So for production level workflows, data and integrating with our existing infrastructure. So that'll be the focus of the next phase. But we can stop it there. We only have a couple of minutes for questions, so maybe we can have 1 or 2. But thank you. That's the actual last slide. And feel free to contact us if you have any questions. And we can even share some of these slides if you want. But yeah, we're happy to take your questions.
Thank you very much. Reminding people that you can put questions in the Q&A. So far, the only question there is, do you know of any attempts to teach AI to create LCSH headings from patterns, like adding in the free floating subdivision of fiction?
Do you mean, do we know of any attempts to train AI models on subject cataloging rules?
Yeah, so that it could create the string itself.
I don't know of any. I know that there's questions about whether or not the model could be fed rules, whether or not it's RDA rules or descriptive cataloging manual rules. I'm not familiar with any of those myself. It's possible that could happen. Then you get into all sorts of copyright concerns. I don't know how ALA publishing would feel about RDA being fed into a model. So for the use of anyone. So I don't have a good answer.
And following up on what you said, I will plug the newly published white paper from the AI and Cataloging Working Group of the RDA Steering Committee. It was published last week. It's available on the RDA website. Some more questions. Were catalogers worried that AI would take their place?
I think every cataloger has that sort of first impression until they get into it and see what it actually is. I know there was a publication out there about, oh, look, it generated this MARC record. Yay, but look how much it hallucinated. Boo. And it's like, that's not a good example of of actual thoughtful AI use in cataloging. That's using ChatGPT to spit something out. You give it a prompt, make a MARC record for this. That is not thoughtful AI. Thoughtful AI is actually thinking about your training data, thinking about, you know, what you've done before and helping to predict what could be. And it's much more time intensive and labor intensive. And in fact, I feel very confident when I say that you can tell your management teams it's not going to save time. In fact, it might eat up more time, at least in the short term. It's not something that you can just sit back and let it do. Like, it takes effort. So if any management team thought, oh, we're going to do this because it's going to be great, we'll be able to save resources. Not in the short term, for sure, and maybe not even in the long term. And you might need to actually hire some people to be able to do some of this work, because it takes some IT know-how, it takes some data science know-how, it takes some time to do all this. So it's not, there are things it does really, really well, and maybe it does them really, really well quickly if you know what you're doing. But there's a lot left over to do. And so, yeah, once catalogers got into it, they're like, oh, that's what it can do. And then they got a little bit either frustrated because it wasn't doing what they wanted it to do, or they at least got excited about the idea of being able to tell. One thing we did not have a chance, one thing we have not done, and this is a very important aspect of machine learning in a workflow, is being able to give feedback to the model. So we got results, and we could say what we thought about the results. But in actual machine learning project where you're doing stuff in real time, you need to be able to give the model feedback to say, oh, no, not that wasn't right. This is what we want. So it's a constant in and out. There is no like, boom, it's done. So that's why, you know, the example of, you know, that paper where it's okay, here, create a MARC record. It's like, that's not how it actually works. So I don't know. I'm not trying to say bad things about the writer or anything. It's more so like the idea, the concept of just give me a MARC record. It's like, well, yeah, it can do that, but that's not what AI should be doing. Or that's not how it should be done in a cataloging environment. That was, yeah, a little bit. And I say this on my own, I'm not speaking for my employer.
Okay, that already answers the next part of the question. Did you experiment with authority records? And if not, are you planning to?
When you're thinking, so is this in the idea of using AI to create authority records? Is that maybe there? No, we have not done that. But in the direction of doing that, it's sort of, so if you have a prototype that's presenting to you a list of possible name authority records that might match the name John Smith, and you are not able to identify from that list which is the right one, that's already the first step to knowing you need an authority record, right? So that's going in the direction of that. The next step would be, okay, none of these worked. Okay, then can the model then also create an authority record based on what it sees as data from the title, let's say, from the title page. But how different is that from using a macro that we already use when cataloging? I mean, in our systems, we search the authority file to see, oh, okay, is Caroline Saccucci in there? Oh, no, she's not. All right, then boom, hit F5, boom, a record pops up and it takes the metadata from the authority, from the title page, and it creates an authority record. And it's like, that's not AI, that's a macro. So if you're thinking in terms of, okay, the cataloger is not involved in this process, it doesn't see Caroline Saccucci as the author, it's going to create the authority record because I know it needs to have that, says the machine to itself. Okay, then make it. Maybe. I mean, that's possible. But no, we have not, in that regard, have not really. But I mean, that could be a workflow.
What would be cool is if it could search the entire book and extract information about the author from the back cover, from the acknowledgements.
Yeah, that's a heck of a lot of training. Just FYI. Being able to tell it, okay, can you find it from this page? Can you find it from the copyright page? Can you look in the first, it doesn't have an introduction. Does it say something there? Oh, make sure that you look on the back of the book, assuming you even have a back of the book. Because, what are you looking at? Are you looking at pre-publication metadata? Are you looking at post-publication ebook? Like, different workflows have different, places that you get that data. So there's a lot of prompting to do to be able to do that. But I suppose if you wanted to try it, it could work with a lot of help. I think you see the theme, a lot of help. So a lot of help. Yeah.
Okay, and the next question is, can you tell the models to take only table of contents data to extract subjects?
Sure. I mean, again, that has a lot to do with what you tell the model to, what you train the model to do. And of course, know that not every book has good, either a table of contents, either no table of contents or bad, useless table of contents. Chapter 1, chapter 2, chapter 3, chapter 4, yeah. So, but if the table of contents is useful, certainly you can train a model to do that for sure.
Okay, and I think you already answered this about linking names to the authority data when there's more than one person with the same name in the authority records. Just summarize how that works.
Yeah, so that's the that first prototype, ECD1, where it showed you the subject prototype, but the name prototype was doing that, where it was presenting different names, different authority links to be. And I should also mention, I forgot to mention this, in that name presentation, it was also linking out to VOF, it was linking out to Wikidata, and it was also, there was another thing it was linking out to. So there were other ways you could get at, oh, is this the right name? So it was trying to, other kinds of linked data that it was trying to use to help the cataloger identify how well did it do with presenting, selecting a name. So in the first experiment, we had the catalogers, a set of catalogers reviewing just output. How well did it identify the title and how well did it identify the name? And it's like, don't worry about normalization, capitalization, punctuation, but did it get the words correct as a token? And when it came to names, interestingly, catalogers said it was wrong if it didn't have the date. For instance, Saccucci, Caroline, 1974 dash. But if it only had Caroline, Saccucci, Caroline, they didn't necessarily think that was right if there was an option with the date. And we wondered, well, how did it even know that it should have a date? Because if it's just getting it from the title page, how would it know? And then it was like, oh, wait a minute. These are SIP ebooks. They have the SIP metadata in them that has the date. So of course it can do that. And that's another reason why there was almost 100% chance that it got the LCCN right. Because guess what? They all have an LCCN in them when they're published. That's cheating. Wait a minute. So, which is why we took LCCN out of the experiment for ECD3, because these are pre-publication. They don't have an LCCN in them. But when it comes to the names and sort of having the names as options, yes, the cataloger could then look and see, okay, which of these names would be the right one. So that's how it would, and again, it was going against id.loc.gov as URIs. And as you know, or might know, BibFrame is very heavily linked with ID. We need those linked data elements. So that's why I was searching against the linked data forms of the names. And identifiers are always easier for a machine to process anyway. So I don't know, I think, did I answer that question?
Yes, thank you. And I see we are over time and I don't want to keep you from getting into work. I would like to thank everyone for attending. I would like to thank the University of Haifa for hosting this webinar series. Our Thursday is Sunday, is the equivalent of Sunday everywhere else in the world. So next week we will sent out a link to the recording so that people can rewatch it, because this was very information dense, and so we can send it to our managers. Thank you all. Thank you very much for presenting and being willing to start your day with us. And thank you to everyone who attended. And we will send you information about future webinars. To the Israelis, please save the date, the 25th of February, the annual Catalogers Update Day here in Jerusalem at the National Library. Hope to see you then, and have a good weekend.
Bye. Thank you.